Okay, y'all. So today is the 15th, which is Tuesday, and we're going to go over the 9.1 correlation and regression PowerPoint, all of the slides. There are a lot of them, and I don't actually have the technology to show you me working on my calculator. I'm not even going to lie to you. I threw the TI 30XA across the room this morning. I do not like this calculator to do two variable stats. So I went ahead and spent this morning trying to figure out basically how to do everything. I did find an instruction sheet, which is this right here, and I have shared it on Canvas. It does make sense. I can explain this to you. The only thing is I accidentally took the stat off of this calculator by clearing its memory completely and can't for the life of me figure out how to put it back on. So I will be using a TI 84 Plus C Silver Edition to do the work today. Right here, literally right here, where it says correlation is how you will do it on your calculator. It is not hard. I just messed mine up. Please email me any questions. You'll enter the data and then press second and then the sum of X. And then you'll enter another piece of data and then press second, the sum of X squared. That's what differentiates your X and your Y values. And then you just go on and so forth. And it's what 4 steps, and you'll be able to actually calculate your correlation coefficient, which is our rho, which not that's not our rho, I'm sorry, that's our R, and that is actually what we're looking for today. But again, for this video I will be using my 84. Okay, so let's go ahead and get started. Again, lots of slides. Okay, just a warning, just a heads up, lots of words. Okay, so chapter 9 is correlation and regression. 9.1 is actually our correlation. 9.2 is linear regression. 9.1 is what we're doing today. The objectives today, it's just an introduction to linear correlation. Linear just meaning line, independent and dependent variables, and the different types of correlation that we can find within our data sets. We're going to actually learn how to find a correlation coefficient, and we're going to see how to test a population correlation coefficient. That little lowercase p is actually called rho. And we're going to figure out how to test that using a table. I believe we do a two-tailed test. We'll actually perform a hypothesis test for a population correlation coefficient rho, and we'll be able to distinguish between correlation and causation. Y'all, just a heads up, there are 9 problems on your homework. This like 40 slides is a lot more complicated than you need to do your homework. But if you don't watch it, you're not going to catch like the little subtleties that are important to be able to do your homework. So I would just take notes. Okay. Okay, so what is correlation? Correlation is an actual relationship between two variables. So we could take the heights of everyone in class and their weights, and we could actually have those two variables. Our X variable could be everyone's height in inches, and our Y variable could be everyone's weight in pounds. And then what we could do is we could actually create an X and Y axis, and we could make like a scatter plot. And what we could do is see if there is a relationship between the two variables. That's technically what we're doing today. Okay. The data can be represented by ordered pairs, which is commonly open X, comma, Y close. X is the independent variable, or the explanatory. I can't talk today. I'm definitely struggling. And then Y is the dependent, or the response variable. Okay, so like I just said, like we could create a scatter plot, right? So what's a scatter plot? You could have an X axis and you could have a Y axis, and you have your data going along your X and your data going along your Y, and you'll actually create coordinated points. And wherever that coordinated point is, where your X and your Y are, you would just put like a dot, and you have all these little different dots and they're scattered amongst each other. And so that's why it's called a scatter plot. Okay. The independent or X variable is measured on the horizontal axis, horizontal like horizon. So it's your X axis, which is why it's the X variable. And then your dependent, which is your response variable, is measured along your vertical axis. Vertical is up and down, and that's why it's your Y variable, because that's your Y axis. Okay, so a scatter plot can be used to determine whether a straight line, remember it's a linear correlation or just trying to see if correlation exists. Linear just means line. So we're trying to see, can we draw a straight line through all of these different data points and be able to determine, usually you kind of guesstimate at first. I think on the homework, you kind of really just do more of computational work than you do guess. But the goal is to see, can a straight line be used or drawn through this data to where you can determine that there is a correlation between your X and your Y variables. So the first one that we have in the top list on all of these examples, we have an X and a Y axis, and we have all these dots. We have all of these little points that have been plotted and they're scattered. The top left, where it says negative linear correlation, if you notice, so you read graphs, right? From the left to the right, you would start right here at the origin and you could move your hand to the right. As you read this from the left to the right, you notice on a number line going to the right on your X axis, your like numerical values would be increasing. So as I keep losing my mouse, as your X increases, right here, if you look at your Y axis up top, obviously would be like a higher value. And then as you move down your Y axis, that would be a lower value. So you're noticing here that as your X is increasing to the right, your Y is decreasing down. So that's why the scattered plots, that sounds funny. The scatter plot, if you pay attention to these dots, here we go. They tend to be going at a like negative slope. Okay, so as X increases, Y is decreasing. And that is fairly close together. So we could say that that has a negative linear correlation. There is a straight line that we could draw through that right there, and it would kind of match our data. If you move to the top right, we see a positive linear correlation. Again, as far as slope is concerning, there is a straight line that we could draw that as X is increasing to the right, we also notice that our little points, right? If this is an X value and this is my Y value, this is where I plot it. Then as I scoot over to the right, it also is increasing on the Y. So that would be positive. That slope is going up, like you're walking uphill. The negative one, you're walking downhill. Okay, so if you look at the dotted line that I could draw through that, the majority of the data is going to be closely related to. So we would say that there's no correlation. There's no pattern. There's nothing that we could distinguish even close to it making a pattern of a line. And then if you notice over here on the bottom right, we have a non-linear correlation. There may be some kind of pattern or trend or something that this data is following, but as far as a line, linear, there's not a line that I can draw through these points of data. It would more so be like a parabola, which is not what we're dealing with right now at all. Okay. Okay, so what we're going to do is, I'm trying to think of what we go here. Okay, that just kind of shows it. I'm not actually going to get my calculator just yet for this. The data is so erratic and all over the place, and I'm afraid it wouldn't even give you much to look at in your, like in the window. I'm just going to kind of explain what they're doing here. So constructing a scatter plot. It says an economist, I can't even talk, economist, there we go, economist, wants to determine whether there is a linear relationship between a country's gross domestic product, known as GDP, and carbon dioxide, known as CO2 emissions. The data are shown in the table. Display the data in a scatter plot and describe the type of correlation. Again, using your calculator, I wouldn't really recommend it right now. We're just going to talk about, ow, 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 I'm trying to move, sorry. the different types of data here and how we have X variables and how we have Y variables. Okay, so we have in trillions of dollars this first column of data points, which are our X values. And they just have a list of different values. I know you can probably hear a lot of noises. I'm sorry. I was not comfortable. I just moved positions. Okay, so we have like 1.8, 1.3, 2.4. And if you notice on the right, that's actually going to be the different type of the CO2 emissions in millions of metric tons. So we have all this different data. Now, if again, don't do it, but if you put this into a calculator and, or you actually just sketch it, you could sketch this probably easier. And you plot all these different points, you're going to get a scatter plot that is very similar to, we have our GDP, which was our X values here on the X axis. And then we have our CO2, which was our Y variables. All of those values are right here on our Y axis. And then this is actually going to be all of the different data points. Because your Y gets so large and your X is so small, I think that's why it looks very, very, very messed up on your calculator. But I think if you look at this, you could actually draw a line and you could see some kind of correlation. Okay, so it appears to be a positive linear correlation. You could get a piece of paper, lay it on the origin at an angle, get your pencil, and you could draw a line, and you can notice that there is like a line that is going to like match this data. Reading it from left to right, the GDP increases as the CO2 tends to increase as well. So both of them increasing is what gives it like that positive slope. Okay, so this one right here, we're actually going to go ahead and do. If you have a Casio, I don't really know. I'm actually hoping moving forward, we can work with that one. You might want to get the little $12 calculator. Not too sure at the moment. As far as a TI 83 or 84, you can follow along with me. And I will help the ones with the TI 30XA. I just can't right now. Okay, so a student conducts a study to determine whether there is a linear relationship between the number of hours a student exercises each week and the student's grade point average, or GPA. The data are shown in the table below. Display the data in a scatter plot and describe the type of correlation. So we have the number of hours of exercise, which is that first row, and that is going to be our X values. And then we have the actual GPA or grade point average, which is that second row, which is going to be our Y values. So if you turn on your calculator and you just press clear, clear, clear on the top right near your like your directional buttons, what you do is if you push the stat button, just says STAT, the first thing that pops up is going to say edit. And if you hit enter, you should be given a number of these different lists. The first one is L sub 1, which is list 1, and then we have L sub 2, which is list 2. Now, under list 1, that whole column, we're going to type 1, 2, and then press enter. It moves down a row. And what we're going to do is we're going to type 3 and then 0, 6, 10, 2, type all of those X values. As soon as you get